Alright guys, let me know when you see me. Should be coming through any second here. If you're in the chat, feel free to say hi. And in about a minute or two, once I know we got some people watching, we will go ahead and get started. Alright. Well, we got at least one person watching, so that's good news. Alright, so we are going to be doing a review of graphing. That's what we're going to be taking a look at today. Okay, so we're going to be taking a look at graphing, and the biggest thing for us to understand about graphing is that we've got some kind of basic things that we really need to make sure we understand, okay? The first basic thing that we need to make sure we understand is the concept of like kind of why we need to graph. Okay. And the concept of why we need to graph really comes from the fact that if you've got maybe an equation like 3x plus 2y equals 5, we really don't have a way of solving that equation, right? There's lots of different x and y values that could work. The first one that comes to mind is x equals 1 and y equals 1, right? If we plug those both in, it would make the equation true. But we have a lot of different solutions that would make the equation true, okay? So that's going to kind of come into play when we're graphing with making a table, where we explicitly look at those solutions. There's a couple other concepts that we need to understand, but the biggest one for sure is slope. Slope is by far the biggest concept that we need to understand, okay? And slope can be defined a lot of different ways. Slope can be defined as rise over run. Slope can be also defined as the change in y over the change in x. That's my personal favorite way, because then I keep the y and the x kind of in mind, okay? The other thing that we need to understand about slope is positive and negative slopes. Positive slopes will look like they're going uphill as you go from left to right, and negative slopes will look like they're sloping downhill as you go from left to right. Okay, those are kind of the major concepts we have for graphing. Okay, now we're going to look at specific problems, but it's always going to be important to keep kind of these different basics in mind. Okay, so first things first, let's head back to this problem. Okay, the directions for this one were graph by making a table. Okay, so what you're doing when you make a table is you're basically making a list of the x and y values that make the equation true. Okay, so typically I showed these in like a little XY chart. Okay, and what you're really doing is you're kind of putting in blanks for both X and Y. And you're trying to figure out, well, what could I plug into both of those blanks to make the equation true. Okay, and you're just trying to do as many as you can, but typically you want at least 3. Okay, so the first thing that comes to my mind is -5 and 0, right? -5 plus 0 would be -5, so I get -5, 0. Okay, that one works. I'll kind of erase and go again. Next thing that comes to mind for me is 0 and -1. That one certainly works, right? Because if I multiply all that out, I get 0 plus -5. And then I need to think of one more. One more good one that seems to work would be 5 and -2, because that gets us 5 plus -10. Okay, so 5 and -2. And if I plot all those points, so remember, each of these then corresponds to an ordered pair. You don't actually have to write out the ordered pair. This means the same thing, but some of you are just kind of more familiar with it in that form, so I want to make sure that we're seeing that too. Okay, we would just now plot these 3 points on our graph. So -5, 0 is right on our x-axis. 0, -1 is on our y-axis. and 5, -2 is kind of out in the middle of nowhere, okay? We would, at that point, connect them with the best line we can. I actually did okay there, and we're all good. And this is the reason that we usually pick 3 points. The reason we usually pick 3 points is because then it kind of allows us to double check our work. Otherwise, we don't really have any good way of doing that. Okay? That's it for that first one. Again, as always, let me know if you have any questions as they come up. Okay. Our next one simply said find the x and y intercepts and create the graph or something along those lines. I'd have to see the specific directions, but it was important that we found the x and y intercepts. Honors group, I know we've talked about this a lot lately, but in regular group I've tried to enforce this too. But the way you find x and y intercepts is you plug in 0 for the other variable. So if I want to know my x-intercept, I plug in 0 for y. If I want to know my y-intercept, I plug in 0 for x. So let's find my intercepts here. Oops. Let's see, here we go. 2x plus 3 times 0 equals 12. Now, a lot of times you guys probably won't really write all of that out. Right, what you guys will probably do and say, you might skip that 3 times 0 part and just skip to 2x equals 12. But big thing, okay, is that our x-intercept is 2, or is not 2. I divided by 2 and I get 6. Okay, so my x-intercept equals 6. Okay, and we can turn that into an ordered pair, right? 6 is what I got for x, 0 is what I plugged in for y. That would be an ordered pair. So I plot that. It's right here on the x-axis. Okay, then I'm going to kind of do the exact same thing for my y-intercept. And with my y-intercept, I'm just plugging in 0 for x. Again, you're plugging in 0 for the other variable. So I'm going to do 2 times 0 plus 3y equals 12. I get 3y equals 12. This time after dividing by 3, I get y equals 4. So my intercept is 0. See, that's what I plugged in for x this time, 4. Plot that on my graph, and I'm good. If I wanted to find a third point to kind of confirm, I could. Well, that was an unfortunate line. Sorry about that. Having a little bit of trouble drawing lines on the iPad. Okay, so kind of first things first. Both of these were similar types of problems. Okay, like in the first one, we actually found both the x and the y-intercept, right? The x-intercept is -5, y-intercept is -1. But we didn't have to do that. We could have found any 3 points on the graph. 2, I was specifically asking you to find the x and y intercepts to make sure you could. Okay. For the rest of these, all we're going to do is graph. Okay. There's no explicit directions other than graph. And the thing we need to keep in mind is that what form is it? Okay. So this one, number 3, is in slope-intercept form, which we usually write as y equals mx plus b. Okay. I'm not really sure why m or b need to be involved there, but m is slope and b is the y-intercept. Okay, so basically the idea there is I am going to label my slope and my y-intercept. In this particular one, my y-intercept is -5. And my slope is 3/4. Okay, we talked about slope. It's rise over run. It's change in y over change in x. And we need to make sure we plot our y-intercept first. This is kind of one of the big mistakes that people often make. We need to put our y-intercept first because all our slope really tells us is our direction, our general direction that the line's moving. It doesn't tell us where to start. We need a starting point. Okay, so in this case, that's our y-intercept. That's our b. Okay, we'll go up 3 over 4. And that gets us to right here. Oops. It doesn't look like we have a whole lot of room to go the other way, so actually that's just going to be kind of where we stop. But again, I went up 3 over 4. It's a positive slope, so I see that uphill thing going there. Okay. So hope that totally makes sense. If it was negative 3/4, I would have just made sure I went the other direction. I still would have gone up 3, but then I would have had to go left 4. Again, I think one of the things that would be super helpful is anytime you're doing a problem where slope is involved, double check what your slope looks like in the end. Make sure it looks positive or looks negative, or just go back and look. Do all my positive slopes look the same? Do all my negative slopes look the same? Reagan asked what would it look like if it was a negative 3/4. She said, whoop, never mind. But just to be sure, if we had the exact same line, but with a slope of negative 3/4, I can just put that in a different color. You would go up 3 and you'd go left 4. Okay, so you'd end up right there, and the line would look more like this. Okay, you can pretty much, guys, you can kind of go whatever direction you want. Okay, really, you can. Okay, so like you could start going up, you could start going down. It doesn't really matter. But then you've got to make sure that the way you go left or the way you go right gets your line to look positive or negative. Okay, negative's that downhill look, positive's that uphill look. Lucy asked, how do you know 3 is y and x is 4? Honestly, that's just our definition of slope. Slope is always change in y over change in x. And I could go into a lot more detail than that. So like if you have further questions on it, for sure, come talk to me tomorrow. But really, slope is always, the top number is always going to be your y, and the bottom number is always going to be your x, always for slope. Okay, so that makes it pretty easy. Okay, good there, hopefully. All right, if you got more questions, keep letting me know. This one I put on there for a couple specific reasons. Looks like we're going to get to negative slope anyway, so that's great. But I put this one on here because it's got apparently no y-intercept. Okay, I would still consider this slope-intercept form for sure. Okay, the difference is that I don't have that. Okay, so I'm going to assume it's 0. The reason I'm going to assume it's 0, and a lot of times in math we assume things are zeros and ones, and we have to understand why. I'm assuming that's a 0 because if I add 0 onto the end of it, it doesn't change the value of my problem. If I added a 1 or any other number, it would change the value of my problem. Okay, so in this case, my y-intercept is 0, and my slope is negative 4/3. Okay, so I'm going to start at 0, 0, because my y-intercept is 0, so that's right in the middle. Okay, and then here's what you're going to do. Again, keep in mind that top number is change in y. Bottom number is change in x. Big thing. It doesn't matter whether you go up or down to start. Like, I know I got to go change in y is 4. Okay, I could go up 4 to start, or I could go down 4 to start. It really doesn't matter. Okay, I put little dash lines there just so you can see what I'm thinking. Like if this were in person, you'd be able to see me physically moving my pen up or down, but I'm just putting them there. We wouldn't put those on a regular graph. Okay, if I went up 4 and I'm trying to create a negative slope, think, what direction would I move to create that downhill look at the end? Notice how I paused briefly and just kind of stared awkwardly at you. I would move 3 to the left if I went up first. Okay, because I can kind of see, oh look, that line goes down and to the right. It's downhill. Okay, same thing if I could choose to go down 4 first instead, right? And then I would move 3 to the right. Okay, because again, that's what's going to give me that downhill look. Okay. There's lots of other ways you can remember positive and negative. I just really, for me, positive uphill and negative downhill has worked pretty well. There's other ways you can remember too. If you need a different way of remembering it, come talk to me. I've got some other ways you can remember too, but that's always been kind of the easy one for me. Okay, but that's what that graph should end up looking like. Okay, doesn't matter if you go up and left or down and right, you kind of end up making the same line anyway. Okay, here's where we tend to have problems. Okay, point slope form is what this is called. Okay, the general form for point slope form is y minus y1 equals m, mx minus x1. Okay, so Everybody seems to have trouble using this one, okay? Here's the biggest thing to keep in mind. Once you have your slope, okay, which we do have now, our slope, that's in the same place as m, again. Okay, so if we look at our equation, that's this 1/2 little friend right there, okay? Now, once you have your slope, all you need is the place to start. So we're just looking for any x and y value that makes the equation true, okay? But this one has one pre-built in. All you're going to try to do is create an x and a y that makes both sides 0. This is really super easy to do because we just kind of take it's easy to make things 0. We just take the opposite of what's there, right? We've got x plus 1, so that means -1 would make it 0. We've got y minus 3. Well, positive 3 would make that 0. See, it's really just kind of like we're taking opposites there. That's really all we're doing. Okay, so the way I figured out my starting point, again, I took the opposite of my x and the opposite of my y. It makes both sides 0. Okay, lots of ways you can remember it, but in the end, that quick shortcut, opposite, opposite. Okay, I plot my initial point, -1, 3 is right here. Okay, and then after I plot my initial point, it's a positive slope, so I'm going up 1 and right 2. You can do that a couple times if you want. You don't actually have to. I usually just like to. You can also go down and left. Down and left will still create that uphill slope when all is said and done. Okay. So that's pretty much it for point slope form. Biggest thing you got to remember, just remember which number is your slope, and then try to just make both sides 0. Biggest mistakes people make, they often flip the x and the y, okay, because up in our equation, y is over on the left, x is over on the right, okay, but in a point, in an ordered pair, x comes before y, okay, so that's kind of where some confusion sometimes occurs, but if you keep those things straight, you should be fine. Okie doke. All right. This one, I really put in there just because I feel like some extra practice on point slope form is good, and I put it in there for that little buddy right there. Okay, so our slope is -2, and in a second we'll talk about how to deal with that. Okay, and our starting point is -2. Okay, so remember that's my x, and if I look up where x is in my equation, if I put a -2 in for x, -2 plus 2 would be 0. Okay, same thing for my y's. That's going to be -3, because if I look up where y is in my equation, if I put a -3 in there, it would make it 0. Okay, so I'm going to start at -2, -3. That's right here. Goodness. Then I got to figure out what to do with that slope of -2. Okay, so normally I have rise over run, right? In this case, I don't have rise over run. So I've got to make it into a fraction. Okay, so I just put an over 1. So now I've got -2 over 1. I'm going to go down 2 and right 1. That's an option. Okay, so down 2, right 1. That's an option. Or I could go up 2 and left 1. Either way, I get that negative slope at the end. Oof, be better if I drew a nice line. Okay, I'm gonna actually erase that and do that again because that was really bothersome to me. Do it one more time. -2, -3 is right here. And again, I can go down 2 and right 1, or I can go up 2 and left 1. Either way, remember that top number is always your y, bottom number is always your x. The directions don't end up mattering as long as you create downhill if it's negative, uphill if it's positive. Okay. Again, point slope form, very, very tricky. Big thing to remember, like, again, if you look back at these x and y values, I totally think it makes a whole lot of sense, right? If we look at -1 right there, if I were to plug it in for my x, I would get 0. Again, my 3 for my y, if I would plug that in for y, I would get 0. Okay, that's kind of the biggest thing. You're making both sides 0, and the other number is your slope. Okay, moving right along. Now comes the part where we are writing equations. Okay, and this for some people is really super easy, for some people is really hard, and it's okay. something different, something unusual, something that we don't usually do. Okay, biggest thing here is you have to understand what type, what information do I have, and what equation makes the most sense for me to use. Okay, in this first one, y equals mx plus b is for sure the best thing that you should use. Okay, and that's because the only numbers you have to put in are the slope and the y-intercept. And guess what? You have both those things already. Okay, so we're literally just going to write y equals negative 1/3 x. You could either write plus negative 3, that would be fine, or you could write y equals negative 1/3 x, just minus 3. Both of those would be okay. All right, and that's it. You've written an equation that meets the requirements of having a slope of negative 1/3 and a y-intercept of negative 3. Okay, for number 8, here's what you're going to be doing. You're literally doing the exact opposite of this one. Okay, that is all you are doing. Okay, so just like we tried to find an x and y value that made both sides 0, what we're going to do this time, I'm going to label these really quick. That's my x, that's my y. So what I'm going to do is this. I know my y goes here, my x goes here in parentheses, okay, and all I have to do is figure out what do I put after each of those things to make sure that I'd get zeros if I plugged in 2 and negative 1. So after my x, I'm going to put a minus 2. The reason is, if I plugged in the 2 from my value, I would get 0. Okay, I'm going to put in a plus 1 right here. Okay, and the reason I'm going to do that is because if I were to plug in my negative 1 from my point, I would get 0. Okay, my slope, that always just goes right out in front of parentheses. Okay, so I'm going to write the 1 there. Do I have to always write it? No, not necessarily. But I don't always have to write it because, like, in this case, it's a 1. Okay, so I don't necessarily have to write that. Okay, a couple good questions. So when it says through 2, negative 1, I probably didn't give enough detail on that problem. Basically, like, if you look kind of back up at the directions, I'm guessing they told you something. It's a line with these properties. So all it's telling you is that, like, if you drew your graph, okay, you drew your line, at some point you would reach 2, negative 1. That's all that means. Okay. And one quick thing, because Reagan asked, does y equals mx plus b work? I'm guessing she realizes, no, that doesn't always work, right? Because we use point slope form here. Really, the biggest thing to understand is if you're given the y-intercept, you want to use slope-intercept forms. You want to use y equals mx plus b. If you're not given the y-intercept, so you're given something like this instead, you're given a point that it goes through, guess what? You're using point slope form. Okay. Last one. And probably the hardest one of the bunch, it's the same idea as the last one, except you're not given slope. So the problem is, you can kind of start going through your process. Okay, so you can be like, all right, I need a y here. I need an x here. And you can actually start putting some of it together, right? I'm going to write a minus 2 here. It's the opposite of my x value. Okay, I repeat, I am not writing it because of the negative 2. I'm not writing it because of that. No. No, 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 no. It's not because of that. Okay, it is because of the 2 for my x. And I know that 2 minus 2 is 0. Remember, I'm taking those opposites there. Okay, same thing for my y. I'm going to write a plus 2. Okay, and again, that is not because of this. No, 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 no. Okay, it is actually because of the negative 2. And I know that negative 2 plus 2 is 0. Okay, the big thing I'm missing, though, here is slope. And I have not been given slope. Okay, so that means I have to figure it out. And this is precisely why I like to define slope as the change in y over the change in x. Okay, because if you think about it that way, if you define it that way, this is not so bad now. All right, what I'm going to do is I'm going to quickly label each of my points. So there's an X, there's a Y. There's an X, there's a Y. Okay, so I want to figure out the change in my X values and the change in my Y values. Guys, change really just means subtract. That's what it means. Right? Like if I told you the change in someone's height was 2 inches over a certain period of time, that would basically mean if you subtracted the two heights, you'd get 2 inches, right? So we can kind of look at that. All we're going to do is subtract the y values and subtract the x values, okay? So my y values are 3, and I'm going to subtract -2, okay? My x values are 0 and +2, so I'm going to do 0 minus +2, okay? When I do that subtraction, I get 5 over -2. Or if I want to write it slightly, but not very much differently, I could write -5 halves. And I just put that right up here. Okay. You don't even necessarily have to subtract. I prefer subtraction, but like you can just kind of figure it out. It's similar to subtraction, but not exactly the same thing. You could just be like, all right, from here to here, if I just count, that is up 5. So my y values go up 5. If I go from here to here, my x values go down 2. Right? And then I make them a fraction, 5 over -2. Okay? I prefer subtraction, but that's totally up to you guys. You don't necessarily have to do that. You can just kind of count how do the y's change and how do the x's change. Okay? So again, reminder, major topics. Okay? Really the big one to me is this whole concept of slope. Okay, understanding that it's change in y over change in x, understanding the direction positive slopes go, understanding the direction negative slopes go. Some of you will legitimately just need to memorize positive slopes go this way, negative slopes go this way. That's okay. That's fine. Totally do that. Okay. Some of you will probably need to memorize like y equals mx plus b and what all that means, right? Like we saw in this one. And we saw in this one. And some of you will probably need to memorize point slope form, okay, or at least parts of it, okay, and that's okay. Nothing wrong with that. This is probably the one place where a little bit of memorization will go okay, and it'll kind of help you get through things a little bit more smoothly, okay. And I think the biggest thing in making sure you understand the writing equations part is this one. Okay, understanding that sometimes we might need to be able to calculate the slope. But if you understand that slope is change in y over change in x, you should be good. Okay, that's all I've got on this one. I believe Wednesday we are taking a look at systems of equations. Okay, so some of this stuff will get used again when we look at solving systems with graphing, but we'll also look at substitution and elimination. I am going to try to get that review posted in just a minute as soon as I get off with you guys. So hope this was all helpful. If you have any questions on graphing, feel free to see me at school over the next couple of days. That's all I got. Thanks for joining.